All right, let's look at a solution for the move zeros function. I'm just going to copy this and paste it into my editor here. And I want to showcase, as I go through this, I want to showcase and emphasize some workflow patterns that I found useful, and I've found that other people have found them useful as well. So I always like to just bring in my problem statement into my editor. That way I'm not switching back and forth between things, and I can edit it around and put things on different lines, make bullet points, take little notes, whatever I need to do, and I just have easy direct access to the problem statement. So I recommend that in Learn, copy paste it into whatever you're using, Replit, VS Code, whatever editor you're comfortable with. So this says complete the move zeros function. Okay, I'm just going to do def move zeros. This function takes a single list as a parameter and returns a copy of that list with all the zeros moved to the end. So anytime we encounter a zero in the list, we're just going to move it to the end. This list can contain the following types and single characters. Okay, so these are the examples, and the reason we put these in here like that, if you look at our examples in Learn, we always have this sort of given this input, we expect this output. So it's always this input-output pattern, right? And the reason for that is I want y'all to practice writing tests, right? So we're going to turn this into a test. So this is going to be the input into our function. Let me just do this. That'll be the input into our function. And I'm going to say move zeros, and we're going to print off whatever move zeros returns. There we go. Okay. So now I just have this comment that just tells me what I expect. You can also print off the expectation, whatever. This is just typically the way I do it, but it's not set in stone. You can do it your way. Okay, so already, usually what I do, even before I read through the problem statement, I'll just write the tests first just to get them out of the way. And the reason I do that, and the reason it's important to kind of to write them a little bit, is rather than us just giving them to you, we want you to actually construct them, because you actually have to call the function and pass it the input. So I already innately have a sense of what this function should take in as an input, because I said it takes a list right here, right? I'm literally just saying that right here. So this is already part of my process of the problem description as well. So I'm going to call this list in, because I know it's going to return a list. I like to just take note that this is the input list, and it's going to be a copy. So we'll say list equals list in dot copy, and we're going to return list. Okay, cool. So let's think about this. How would we approach this? I'm going to solve this in a way that is going to, I'm going to intentionally encounter a couple of pitfalls that I encountered when I first did this solution. And I'm going to show how to solve those, because I want to give people a sense of how to go about handling errors when they occur, because they will. It's more important it's a better skill to be able to handle errors as they come up, and arrive at robust working solutions in the end, than it is to be able to avoid errors all the time, right? You're going to encounter errors, so it's worthwhile to get good at handling them. Okay, so the first thing that I did with this is just for element in list in. Now I could go, I have a choice here. I could loop through this list or this list. They have the same contents, but why choose one over the other? Well, there's a general rule of thumb that I try to follow, and it's general. This is not something you need to do all the time, and it's actually an error in this case, but we'll look at why that is and hopefully discover it. So in this case, I'm going to just loop through the input list, and the reason why I'm choosing to loop through the input list is because I intend to modify this list. So the rule of thumb is that generally you want to avoid iterating through the thing that you're modifying. If you have a problem like this, like I think about this as a kind of accumulator pattern, even though you're not accumulating, you're actually reorganizing something, right? I'm changing the order in which the elements occur in the output list. So that's different than strictly accumulating, but it's still like you have a target for modification, you have a loop, we're going to do the modification under a certain condition, and then you do the modification. So that describes a accumulator pattern as well. So I think about this as a kind of accumulator. So whatever I'm using as the target for the modification, when I have a reordering problem like this, by default I try not to also be iterating through the same one, right? Now these have the same contents, but they are not the same list. These are two lists with separate contents. It's important to note. Okay, so I'm going to stick with my convention and iterate through different lists than I'm modifying. So we're going to iterate through this, and we're going to say, what do we want to do? We want to say if the element is equal to 0, if LE equals 0, then we need to do two things. We want to remove the element from its current position and append, just place it at the end. Append LE to the end of the list. Right, so think about what tools you might use to remove an element. And there's a few. There's list.remove, list.pop, and then there's the del keyword for delete. We don't need to capture the element because we know what the element is. It's 0, right? But in this case, my preference is to use pop because it removes the element by its index. And that's a little more precise. To me, it feels a little more precise than removing it by its element. And the reason I'm saying that is, so the dot remove method, you can say list dot remove, and then remove takes as an argument, it takes an element to remove. So if I say list dot remove 0, it will remove an element that matches the argument, which is 0, right? Which is what I want it to do. But what I prefer is to say list.remove this particular index, whatever the index of element is. And okay, so I've written a for loop, and I've had the thought, I need access to the index of element. So if you ever have that thought, your first thing that you should go for is enumerate. Should just go straight to enumerate. So I'll say IDX for IDX and element, and enumerate list in if element equals 0. And this is actually also a small pitfall, and we're going to look at this in a second. We'll discover what else we need to do here. But there's something interesting happening on this line. We'll need to expand that as well. And see if you can anticipate what that might be when I'm checking if element equals 0, right? If we look at these tests, you might ask yourself what might happen in these scenarios. Okay, so if element equals 0, I want to remove, and remember I decided to use pop, so pop. I'll say list.pop idx, and let's just print this off, and I should see all zeros, right? Print. So remember, pop not only, pop not only removes the element at that index, but it also returns the element removed. It's very kind of an odd method. It's not often. Well, let's see here. What have I done? Pop index out of range. Well, that's quite interesting. Did I have... I must have done something silly. List.pop index. Index error, pop index out of range. So that's funny because we're iterating through a collection that is a copy of the thing we're popping from. Oh, right, because I'm not appending it. Joy. All right, so we actually need to, I was going to show this step by step, but when I did this as in my trial run, I did the whole thing in one go. So yeah, let's do it like this. I'm just thinking of how to break this down into like bite-sized chunks. So I'm just going to capture whatever pop returns into res, and we'll append it here. We could just say res.append. Excuse me, res. So this will be list.append res, right? So since I'm only using res in one spot, only using the result in one spot, I'm actually just going to do both in one go. And instead of printing here, let's see what we get on the output. So the reason I want to be clear about this, the reason I was getting that error is we're going through the indices and the elements in the input list, and I was popping, which removes, but I wasn't adding back in, so I was essentially shortening the output list, and then at some point it was so short that I had an index from the input list that was no longer present in the output list because I was popping without appending. Okay, cool. So this is not quite right. If we look at the output right away, we can see, well, the zeros are sort of more towards the right, but in no case are they all the way at the right. And let's look at this a little deeper, right? So let's look at our first expectation. We got 1 false 0 and 2. We expected 1 false 2 and 0. Okay. And then let's see here. Yeah, this last one is kind of interesting. This last one, we expected false, 1, 1, and none, which is actually just equal to the input. So no change. But we got 1, 1, none, and false. So if I think about how we debug this, something has gone wrong. We know that because we're not getting the correct output. So how would I debug this? I'm going to get rid of my comments here. What I want to do is make sure, okay, is element here actually equal to 0? Am I actually getting the correct element that I'm popping and appending? So I could just print Ellie. We'll just print element and see what we get. For now, I'm just going to comment out the return. just to clean up the output, just so there's less to look at. Okay. So if we look here, I get all these zeros and falses and nones. So this is not correct, right? So it turns out, and this is the error with this line, right? It turns out that if I say print, and we'll just do an example of this condition, right? So print 0 equals 0, right? I don't even need to run this. You know this is going to be true. But let's say this, false equal to 0 and none equal to 0. Let's just try these out real quick, right? Because that's evidently what's happening, right? I'm getting all these falses and nones printed here, right? So it says true that false is equal to 0, but none is not equal to 0. So when I was seeing none there was actually the function printing out, since I commented out the return for now. That's what I was seeing for none. So evidently it thinks that false is equal to 0, which is something that Python thinks, which is fine. But we just need to adjust our condition here to only work if we have a numeric, or Booleans actually are a numeric value. But it only work with integer or float values. So what I'm going to do first is say if type element in int float and element equals 0. So now we'll print out, and here we'll just comment out the return. So the nones, again, remember, are just the what's printing out here, since I commented out the return. And so all I'm seeing aside from those nones is the zeros, so that means I've correctly identified the zeros. Okay, let's do this return again. Cool. Now let's go through each one. So for the first one, my expectation is 1 false, 2 and 0, and I get 1 false, 2 and 0. Second one, the expectation is 1 none, 2 false, 1 0 0. The result is 1 none, 2 false, 1 0 0. And the third one is the same as the input, false 1 1 none, false 1 1 none, and the output was false 1 1 none. So this appears to be passing all my tests. Good. Let's go back. There is, well, let's look at this. Remember how I said there was another error with this that I wanted to explore. So let's look at this. So if we look, and I wanted to do this because I wanted to showcase like how to go through and read all this stuff that Learn gives you, right? These are formal, what we do is we write formal tests that test the function, and these are the errors that the tests give when it fails. This is a good section to look for. If you ever see this minus this and plus this kind of thing, what this is saying is, you know, minus meaning it doesn't need this, and plus meaning it does need this. So essentially what this is saying is it found this result, but it was expecting this other result. And if we look, the result it was expecting is formatted correctly with all the zeros at the end, whereas the one that it found obviously does not have all the correct zeros. So let's look at this. I'm gonna come up here and just kind of work my way up. This says assertion error, lists differ. So this is basically telling me the same information here. And I'm going to see this first one, which is the minus list. That's the one we got that we don't need. And it says is not equal to the one that it's looking for. Okay. Then we'll come up another one. It says self.assert equal main.move zeros. Okay, move zeros. So this is what you're looking for. Look for a place where it's it's actually giving you an example of the function. That way you can snag its input, right? So this is the function that we wrote, move zeros. Let me see if I can just copy this. And that tells me what its actual input is and what its output is expecting, right? So actually, real quick, I'm going to just copy this whole line from move zeros forward, and we're going to turn that into a test, right? Actually, let's do that. And I'll say print this to this. This is kind of a longer output, so I'll put that on the next line. Okay. All right, so this is my new test. So given this input, I expect this output. These tests are passing, so I'm just going to comment them out for now. This is the one I'm interested in, so let's move this up to the top. And as we can see, we get that list that isn't quite the right thing. So remember when I was saying, in general, you don't want to alter the same list that you're looping through, because that can cause, I mean, hopefully it's clear why that is, like just intuitively. Oh, excuse me, I didn't switch back to my editor. My bad. Okay, so all I did was just paste this in. Let me show it again. I pasted in the, oh, that was copied. I pasted in the line that I copied from learn, and then I just threw a test around it and commented out the expectation, right? And we can see we're getting the bad result here. So what I was saying is, you generally don't want to iterate through the thing you're altering, because the thing you're iterating through becomes now difficult to predict. It becomes difficult to reason about and think about. So you want to avoid it if possible. In this particular case, there's a disparity between the list that we're looping through and the list that we're altering. There's a disparity across the indices, right? So when we alter the output list, we change the relationship between what element is at what given index, right? And let's do the same test that we did that discovered the prior error, right? The question is, are we correctly identifying the element as a integer or float value of 0? So let's just print element, and if I see a 0, if I only see zeros, and I'll leave this since we only have one test, I'll just see the list at the end, but if I only see zeros, then we're correctly identifying the element. Of course, I actually have to type in the right variable name. Okay, so this is correctly identifying zeros, right? But let's look at this, and this actually would be a little better if I did this res, so we can print out res. So I'll say res equals that, print res. See if you can figure out what's happening here. I mean, I'm going to say it, but, you know, we'll see there. So we know that the elements that we're identifying are 0. Let's see if we're popping off the right thing. So when I print res, which is the result of pop, I'm getting zeros and ones, and that's because as I iterate through, as I change the output list, as I alter this output list, it becomes more and more dissimilar from the input list, and the input list is what I'm using to identify the elements. So in this particular case, I have to settle, I have to bite the bullet, and just iterate through the same object that I'm actually mutating, right? So again, I'm going to get rid of res. We'll do that. Just get rid of this stuff, save it, and we'll see if we get this list here. And it's a little long, so I'm just going to copy rather than having you sit there and listen to me read it out. So those look the same to me. Okay, cool. So let's see if this new modified code will pass. Right, so look, the only change is that I just deleted this part, but so we're just iterating through list. Cool. And that works. Hopefully that was helpful.